And so quadrant 4 is your cos is positive. Quadrant number 1, all of them are positive. Quadrant number 2, sine is positive. And quadrant number 3, tan is positive. So let's take a look at some of the examples now. So some of the examples here, if I take a look at this, example 1. It says the point 512 is on the terminal arm of an angle theta in standard position. State the primary trig ratios and find theta. Now, the point 512. The point 512 means that here is your robotic arm or your terminal arm, and the point 512 would be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, somewhere up here. And so this would be P512. Now, if I draw a line straight down to the x-axis, remember, this thing rotates round and round. If I draw a line straight down to the x-axis, this is 90 degrees. The distance from here to here, the horizontal distance, is your 5, your x value. Your vertical distance is your 12. I can definitely figure out r, if required. R squared is x squared plus y squared. And so r squared is going to be equal to x, which is 5 squared, plus y, which is 12 squared. So radius squared is equal to, this is 25 plus 144. So r squared is equal to, that is 169. Take the square root of both sides. That means r is equal to 13. So r is 13. It happened to be a whole number. Sometimes they're not whole numbers. Sometimes you leave them as radicals. So now that we have x, y, and r, I have enough information in order to come up with the primary trig ratios. Remember, the primary trig ratios are sine theta, right? What's your theta? Again, this opened up. Theta is this. Now, since we are in quadrant number 1, it's very important to understand that your theta is going to be between 0 and 90. It's going to be an acute angle. So, sine of theta, remember, sine is, this is your opposite, this is your adjacent, and this is your hypotenuse. So sine theta is going to be opposite over hypotenuse, or 12 over 13. That is sine theta. Cos theta is going to be adjacent over hypotenuse. So adjacent is 5 over hypotenuse is 13. And tan theta is going to be opposite over adjacent, so that's 12 over 5. So these are my 3 primary trig ratios. Now, it's also asking me to find theta. So I'm going to find theta, and if I go to find theta, which trig ratio do I use? And the answer is, it doesn't matter. They'll all give you the right answer. So if I use, let's say the first one I found, which was sine theta is equal to 12 over 13. If I go to find theta, I'm going to have to bring sine to the other side. So theta is going to be equal to sine inverse of 12 over 13. And so, theta is going to be equal to, if I have a calculator number 2, so I do 12 divided by 13 first, and then take the sine inverse of that, and I get roughly 67.38 degrees. Okay? Now, if you did the same with cos or tan, they should all give you the exact same answer. Okay? So let's take a look at example 2. Example 2 says the point -4,3 is on a terminal arm with the angle theta in standard position. State the primary trig ratios and then find theta. So again, same type of question. If we draw a Cartesian plane here and we draw our terminal arm and it rotates to the point -4,3. -4,3 is -1, 2, 3, 4, 1, 2, 3. So this is where the terminal arm opened to. I drew the terminal arm too big right here, but that's where the terminal arm opened to. Maybe I should have drawn it that big. And remember, it rotates around in a circle. So this is your theta. That's how much you opened up by. Just remember that the angles between here in quadrant 2 are angles between 90 and 180. Now, if I draw a line straight down to the x-axis,
participating in the walk so kids can talk. Trip, please.
This is your x, this is your y, and so my x-coordinate is -4, and my y-coordinate is +3. That makes this point -4, 3. Now, of course, I can figure out my radius, because my radius, I know my radius is r squared is equal to x squared plus y squared. So r squared is equal to x, which is -4 all squared, plus y, which is 3 all squared. So r squared is equal to, this squared is 16 plus 9, so r squared is equal to 25. Taking the square root of both sides, r is equal to 5. So I know that this side is 5. Now, according to this theta, this is my opposite side, this is my adjacent side, and this is my hypotenuse side. So if I go to figure out my sine, cosine, tan, sine theta is going to be equal to opposite over hypotenuse. Opposite is 3 over hypotenuse is 5. So this is sine theta. Cos theta, if I do cos theta, that's adjacent over hypotenuse. Adjacent is -4 over hypotenuse is 3. So that's cos theta. And tan theta, I'll write down here, tan theta is equal to opposite over adjacent. Opposite is 3, all over adjacent is -4. So, then it asks me to find theta. How would I find theta? Well, how I find theta is how I normally find it. Just remember that theta, though, is an angle that is bigger than 90 but less than 180. So if I use my sine and I do sine inverse of this 3/5, I'm going to end up getting, and again, I'm going to use my calculator here, and I have a calculator number 2, so I'm going to do 3 divided by 5 first, and then take the sine inverse of that, and I get 36.9 degrees. Now, clearly, this is definitely not 36.9 degrees. That is not the correct answer. So why did this not give me the correct answer? What kind of answer is that? So we'll answer that in a second. Now if I use my cos and do the same thing, I'm going to do the cos inverse of, this is -4/3. And if I do the cos inverse of -4/3, and again, I would do -4 divided by 3 first, and then take the sine inverse of that. So -4/3. And there's actually a problem here because it's actually not over 3. This is my fault. Remember, cos is adjacent over hypotenuse. Hypotenuse is 5. My fault. So cos theta should be -4 over 5, and that -4 over 3. So if I do cos inverse of -4 over 5, I would get, I will get 143.1 degrees. And does this make sense? And the answer is yes, because you know what? Theta is bigger than 90, but less than 180. I know that from this picture. So this is the correct answer. So why did cos give me the correct answer, but sine did not? What is sine actually giving me? We'll answer that in a second. Let's look at tan. Tan being opposite over adjacent, 3 over -4. If I do the tan inverse of this 3 over -4, I'm actually going to get, plugging this into my calculator, -36.9. So is this the right answer? Well, no, it's not. The first thing, it's negative, and the second thing, it's not a number between 90 and 180. So what exactly is this telling us? So how can I use sine in order to give me the right answer? Because all 3 of those things should be giving me the right answer. What is 36.9? What is it actually telling me? What it's telling me is in this picture, this is the 36.9 right there. That's the 36.9. So in order to fix my answer using sine, you know that half a circle or a straight line from here all the way to here is 180. So I would do 180 minus 36.9. And that would give me 143.1. So I can obtain the correct answer using sine as long as I know that we're in quadrant 2 and as long as I know what sine is giving me. Sine is giving me 36.9. This is the 36.9. So I would subtract that from 180 and that gives me 143.1. Same with this. Tan is actually giving me negative 36.9. It's actually telling me to start at 180 and subtract 36.9. Go 36.9 backwards. And this also would give me 143.1 as long as I know how to fix it. So it's very important that you understand in quadrant number 1, this question, they gave you all the right answer immediately. In quadrant number 2, it was a little more difficult to give you the right answer. Cos gave you the right answer immediately, but sine and tan did not. You can fix them. So this is how the quadrants are numbered. We know the cast rule already. Let's take a look at example 3. So example 3 says evaluate to 4 decimal places. So let's evaluate these things here. So this is now a little different than what you're used to doing. Now, obviously, if you do this on your calculator, you can evaluate sine of 133, no problem, and you will get 0.7314, sorry, if I evaluate that properly. And, of course, cos of 121 and tan of 200, you can do that on your own, okay? So not a big deal. But what is a big deal is something that looks like this, because sine A is equal to positive 0.3214. So what does that mean? What that means from now on is that, remember the lesson, this lesson deals with trig ratios for all angles between 0 and 360 degrees. So if I take a look at this and I understand what I'm dealing with here, and I know the cast rule states that cos is positive here, and over here sine's positive, over here tan's positive, okay? If I have sine A equals 0.3214, is this a positive or negative number? It is positive. I'm dealing with sine, and sine is positive. Where is sine positive? Sine is positive in this quadrant, and sine is also positive in that quadrant there. So in actuality, when I'm trying to find an angle A, there are going to be two answers. Sine is positive here and here. So you'll see in a second why. If I go to solve this normally, if I bring sine to the other side, sine inverse of 0.3214, if I do this, and I do the sine inverse of that, I'm going to write this in my calculator, so 0.3214, and take the sine inverse of that, I get 18.7 degrees. Now, how do I know I'm correct? If I plug in 18.7 degrees, remind you this is a rounded answer, if I do sine of 18.7, it should give me this number, or close to this number because this is rounded. But that is only one answer.
Attention students, the Walk So Kids
So,
Talk meeting is starting now in the chapel.
If I want to find my second answer, how do I find my second answer? My second answer is found, and my second answer is in quadrant 2. So remember, my first answer I got was 18.7. My second answer is in quadrant 2. So I have to figure out what this angle is in quadrant 2. How do I do that? The exact same way as I did my last problem. I'm going to take 180 and subtract 18.7. That is the only way I can end up in quadrant 2. And so if I do this, 180 minus 18.7, I'm going to get 161.3 degrees. So this